Today we're going to talk about synthetic division for polynomials, and this can be used sometimes but not all, which is why we still have to know how to do long division. So go ahead and for this first one, do divide this problem using long division. And so then after you're done with that, you can unpause the video and look at the answer, and then we'll do synthetic division. So looking at number 1 for our long division, recall that we have x minus 2, and then the dividend is x cubed, and then plus 2x squared minus 6x minus 9. We are not missing any zero placeholders, so we don't have to worry about that. And then does McDonald's sell burgers? Repeat is what we use to help us remember the steps. So for this, the work is off to the side. So D stands for divide, so x cubed divided by x. You always divide the first terms. Gives me x squared, and then you put that above the quadratic terms. M stands for multiply. X squared times x is x cubed. X squared times negative 2 is minus 2x squared. And then remember, S stands for subtract, so we're going to change the signs. This cancels out. 2x squared plus 2x squared is 4x squared, and then B stands for bring down. And then R stands for repeat. So for the next part, 4x squared divided by x gives me 4x. It's positive, so plus 4x goes above the linear terms. And then multiply 4x times x, which is 4x squared. 4x times negative 2 is minus 8x. And then again, you're going to subtract. So this becomes minus, this becomes plus. So this cancels out. Negative 6x plus 8x gives me 2x, and then bring down the minus 9, and then start all over again. 2x divided by x is equal to 2, so plus 2. 2 times x is 2x. 2 times negative 2 is minus 4. Subtract, so change those signs. This cancels out. Negative 9 plus 4 gives me negative 5, so that's the remainder. And so then my solution is x squared plus 4x plus 2 minus 5 over x minus 2. So that is long division of the polynomial. So today we're going to talk about a new way to divide, which is called synthetic division. So synthetic division can only be used when the divisor is a linear binomial with a leading coefficient of 1. So for this, what is the divisor? X minus 2. What does a binomial mean? It means two terms, which this is. The leading coefficient of this is in front of the x, so that is 1. So that means we can go ahead and do synthetic division. So over here, when we're doing our synthetic division, where did the numbers 1, 2, negative 6, negative 9 come from? Well, notice they came from our dividend, x cubed plus 2x squared minus 6x minus 9. And if I put the 1 in front here, so these are the coefficients of our dividend. So the 1, 2, negative 6, negative 9. So we just take out our x's and we're going to put them back in later. What goes inside this partial box over here? Well, you find the 0. So x minus 2, if I set this equal to 0 and solve, I get x equals 2. And that's the number that goes in the box here. Unlike long division of polynomials, instead of subtracting, we're going to add. And that makes sense because look up here. If up here we're changing the sign, right? We're taking this negative 2 and putting it on the other side. So we already are taking into account the subtraction by changing the sign of what our number is in the box. So then the steps are to bring down the first term, which is 1, and then you multiply 1 times the number in the box. So 1 times 2 is 2, and then you add these together to get 4. And then 4 times the 2 is the next step, which is 8. Add the negative 6 plus the 8, which gives us 2. 2 times negative 2 is 4. Add these together to get negative 5. So now that we have this part right here, that last number is always the remainder. So I usually put a line there to remind me it's the remainder. And I have to put my x's back in. So how do I know what to start with? If this is a cubic function, it's always 1 less than your dividend. So 1 less than the dividend power, which is x cubed, would be x squared. So x squared, this is plus 4x plus 2, and then the last number is always the remainder, so minus 5 over x minus 2. So notice that we got the same answer, it's just a different way of dividing. Just like long division, if we were missing any zero placeholders, we would also want to make sure to put those in. So let's go ahead and do another one. So looking at number 2, first thing I would look at is my divisor. This is a linear binomial. The leading coefficient's 1, so I can go ahead and use my synthetic division. So I'm going to set it up. So I look here, x cubed, so this is degree 3, 2, 1, 0. I'm not missing any zero placeholders. I can go ahead and write the coefficients. So the coefficient here is 1, 2, -6, and -9. And for these, we're always adding. The number that goes in the box is the 0 of the divisor. So set this equal to 0 and solve. We get x equals -3. So that's the number that goes in the box. Bring down that first term. And then you're going to go ahead and multiply. 1 times -3 is -3. Or 2 minus 3, I should say, is -1. Then multiply. -1 times -3 is 3. Add these two terms, -6 and the 3 together to get -3. -3 times -3 is +9. Add these terms together and that gives us a remainder, which is 0. So if this started off with x to the third power, then down here we start off with 1 less than that degree. So this would be x squared minus 1x, you don't need that 1, minus 3. So this is our solution, which means that x plus 3 is a factor of this equation because we didn't get a remainder. Go ahead and see if you can try number 3 on your own. When you're done, you can unpause the video. So go ahead and look at our divisor. It's linear binomial with a leading coefficient of 1. What number goes in the box? So this would be x equals 4 when we solve by setting that equal to 0. And then here, notice that this is degree 3, degree 1, and degree 0, so that means we're missing degree 2. So that means I need to add that 0 placeholder in. So 1, I need that 0, 7, and -5. Bring down that first term. 1 times 4 is 4. Add these terms together. 4 times 4 is 16. Add these terms together. 23 times 4 is 92. Add these together. And that last number is the remainder. So this is degree 3, so that means down here we start off with degree 2, so x squared plus 4x plus 23 plus 87 over x minus 4. All right. The next one says factor the polynomial completely given one factor. So remember, this means the remainder is equal to 0. So that should always happen if it's a factor. So if we want to factor this polynomial, remember we said that when we do synthetic or long division, when we get a remainder of 0, that's factoring the polynomial. So I can take this and use synthetic division because this is a linear binomial with leading coefficient of 1. This is degree 3, 2, 1, 0, so we're not missing any 0 placeholders. So if I set this equal to 0, we get x equals -2, so that goes in the box. Then we have the coefficients 1, -5, -2, and 24. Bring down the 1. 1 times -2 is -2. Add these together. -7 times -2 gives me 14. Add these together. 12 times -2 is -24. Add these together to get the remainder because that's the last number. So this is a remainder of 0, which we like. So that gives me, this is degree 3, so x squared minus 7x plus 12. So now I have x plus 2 I know is a factor, and so is x squared minus 7x plus 12. Notice we ended up with a trinomial, so that means I want to see if I can factor this further. Do I have factors of 12 that add up to 7? So when I set up this to see if I can factor, we know that the signs are both negative because this is positive and this is negative. So that would be factors of 12 that add up to 7 are 4, negative, and negative 3. And so this is completely factored. Go ahead and see if you can do the next one on your own, and then when you're done, on pause. So this is a linear binomial. Set it equal to 0 and solve. We get x equals 4. So in the box goes 4. So then we take our coefficients. Bring down the 1. 1 times 4 is 4. Add these together. Negative 4 times 8 gives me negative 32. Add these together to get negative 20. Multiply negative 20 times the 4, which is negative 80. So again, we get a remainder of 0. We're happy. And we can go ahead and this is degree 3, so this would be degree 2 x squared minus 8x minus 20. And of course, that's being multiplied by the x minus 4, so that means that those are factors of that polynomial equation. This is a trinomial, so do we have factors of negative 20 that add up to negative 8? So negative 10 and positive 2, so x minus 10 times x plus 2 times x minus 4 is my complete factorization. Another way that I can check to see if this is going to be a factor without doing the synthetic division first is I can plug that number that I think is a 0 into the equation, and I should get a 0 out. And why does that work? Well, think about it. So if we're saying this is a factor, then that means it should be an x-intercept on the graph. So if this is an x-intercept, then what's the y value for your x-intercept? Your y value is equal to 0. So if I plug in negative 2 for all my x's and get 0 out, then you know it's a factor. So that's something that you could do if you wanted just to double check your work. So just to show you, if I plug that into my calculator, go to my y equals, you can plug it into your y equals, or you could plug it in just to the actual equation. It doesn't really matter. So let's actually go to the home screen. So if I plug this in, I have negative 2 to the third power, and then minus 5 times negative 2 squared minus 2 times negative 2 plus 24. And notice that gives me 0. And again, that's because it's an x-intercept on the graph. So that x-intercept, we would get f, so f of negative 2 is equal to 0 because on the graph, the x-intercept is negative 2 comma 0, because remember, if it's a factor, that means it's a solution, which means it's the x-intercept of our graph. So just another way of checking your work. Looking at the next one, it says find all the zeros of the polynomial function given 1, 0. So again, that means that when you do your synthetic division, the remainder should equal 0. If it does not, then we did something wrong. So now we're saying the 0 is negative 5. So again, you could just plug in negative 5 for your x's. If you get 0, then you know it is going to be 0 of the function. So we're finding all the zeros. Notice it didn't say factor. So if I use my synthetic division, negative 5 goes in the box. Then we have the coefficients 1, negative 1, negative 21, 45. I wasn't missing any 0 placeholders. Bring down the 1. 1 times negative 5 is negative 5, so this gives me negative 6. Multiply, which gives me 30. Add these together, get negative, or not negative, positive 9. Multiply, negative 45. So the remainder is 0, which tells me that it is a factor, which means this is a 0, so that checks out. So then we get this, if I write it as a factor, would be x plus 5, because if you solve x plus 5 equals 0, you get the 0 of negative 5. So then this becomes x squared minus 6x plus 9. And then, of course, we want to factor that further. So x plus 5 times x minus 3 times x minus 3. So factors of 9 that add up to negative 6. So the factorization of this would be x plus 5 times x minus 3 squared. But that's not what we're trying to do. We're trying to find the zeros. So the zeros, you have to set each factor equal to 0 and solve. So we know negative 5 because that's what they gave us in the problem, and x equals 3, which of course, because it's degree 2, is a multiplicity of 2. So that means it occurs twice. So what happens on the graph with a multiplicity of 2, remember that means it hits the graph and bounces back in the same direction. So go ahead and do number 7 on your own. When you're done, you can unpause to check your work. So for this one, we're saying the 0 is negative 2. So in the box goes negative 2, degree 3, 2, 1, 0. We're not missing any 0 placeholders, so I can write the coefficients and do my synthetic division. Bring down the 9. 9 times negative 2 is negative 18. Add these together. Negative 8 times negative 2 is 16. Add these together. Negative 1 times negative 2 is 2. Add those together, so the remainder of 0. So that's good because that means this is a 0. So this as a factor would be x plus 2 times 9x squared minus 8x minus 1. So for this, we want to find factors, see if this factors. So if I want to see if this factors, 9x squared minus 8x minus 1 doesn't have a greatest common factor. So if I have a number in front and that happens, I can use the Swedish fish method. So Swedish fish don't really swim. 9 times negative 1 gives me x squared minus 8x minus 9. Factors of 9 that add it to negative 8 would be x minus 9 times x plus 1. We have to divide that 9 out because we moved it in the beginning. Reduce. So this becomes x minus 1, and this doesn't reduce, so that number swings in front, 9x plus 1. So x plus 2 times x minus 1 times 9x plus 1. This is the factorization, but we want to find the zeros. So we set each equal to 0 and solve. So when I solve, we already know this one, x equals negative 2, because that was given to us. Add the 1, we get x equals 1. Here, subtract the 1, divide by 9, so negative 1/9 equals x. So these are the zeros of my equation, or the x-intercepts, or the solutions. Remember, those all mean the same thing. You could also use the quadratic formula. On 9x squared minus 8x minus 1 if you forget how to factor. So if you forget how to factor, you can always use that quadratic formula. So remember, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, and you would get the same answers. You would get negative 1/9 and 1 for your solutions. You still have to be able to do that synthetic division to get this part right here to use that quadratic formula though. So go ahead and see if you can do 8 and 9 on your own. When you're finished, you can unpause the video to check your work. So looking at question number 8, we're going to go ahead and do our synthetic division. So we're saying the 0 is negative 7. So then we have 3, 2, 1, 0. I'm not missing any 0 placeholders. So 3, 21, negative 15, negative 105. Bring down the 3, and then go ahead and multiply. 7 negative times 3 is negative 21. Add these together. 0 times negative 7 is 0. Add these together. Negative 15 times negative 7 is 105. Add these together. So the remainder is 0, so that means it is a factor. So we can write negative 7 as x plus 7, that's the factor. This becomes, if this is to the third power, this would be 3x squared. I don't need to write the 0x, so if you want to, you can. So 3x squared plus 0x minus 15, I don't need to. So that's the same thing as 3x squared minus 15. This right here factors, so I have a GCF of 3, so I can take the 3 out, that becomes x squared minus 5. And then this does not factor any further. It's not the difference of squares because we can't take the square root of 5. So my factored form is 3 times x plus 7 times x squared minus 5. That's completely factored. So remember I set this equal to 0 to solve. So 3 does not equal 0, so we don't do anything with that. X plus 7 equals 0, and x squared minus 5 equals 0. So we already knew this answer because that was given to me in the beginning. And here, x squared equals 5. How do I get rid of the square? Take the square root. Don't forget plus or minus. So plus or minus the square root of 5. So negative 7 and plus or minus root 5 is our answer, which makes sense because remember we talked about whatever the degree of the polynomial is, that's how many solutions you should find. So in this case we have 3, so this is 1, 2, and that negative 7 gives you the third solution. Looking at number 9, in the box goes the negative 2, so this is 2, 8, 17, and 18. We weren't missing any 0 placeholders. Bring down that 2. 2 times negative 2 is negative 4. Add these together. 4 times negative 2 is negative 8. Add these together. 9 times negative 2 is negative 18. When you add those, you get the remainder of 0. Then my factors would be x plus 2, because that comes from the negative 2. This is degree 3, so this starts off with degree 2, so 2x squared plus 4x plus 9. And so for this, 2 times the 9 gives me 18. There are not factors of 18 that add up to 4. So we're going to have to use the quadratic formula to solve. And so for this, we get x equals, because we're finding the 0, so x equals negative b, so negative 4, plus or minus the square root of 4 squared minus 4 times 2 times 9 divided by 2 times 2, because my a equals 2, my b is 4, and my c was 9. So x equals negative 4 plus or minus. Remember, we always want to find the exact solution when possible, so we're going to simplify what's underneath the radical first. 4 squared gives us 64, minus 4 times 2 times 9 is negative 56 over 4. And of course we can reduce that, so if I just do some work off to the side here, root negative 56, so remember that's going to give me imaginary numbers, so that's I root 56. And 56 breaks down into 4 times 14. Of course you can break that down differently if you want. That's the way that I did it. 2 and 7, this breaks down into 2 and 2. So we're looking for groups of 2. This can go out, this doesn't make a group of 2, so we leave 14 underneath. So 2I root 14. So this is x equals negative 4 plus or minus 2I square root of 14 all over 4. So that gives me negative 4 divided by that 4 plus or minus 2I root 14 divided by 4. So that means that this is equal to negative 1 plus or minus. This becomes I root 14 over 2. So my solutions are x equals negative 2, negative 1 plus I root 14 over 2, and negative 1 minus I root 14 over 2. And of course, you could leave it as plus or minus if you want. Now, you might be asking yourself, why did I not divide the 14 and the 2? Because 14 divided by 2 is 7, because the 2 is not underneath the radical, so you cannot divide them out. That would be your solution right here. And that's it.